Welcome to the second video of Boolean Algebra. So as we talked about the applications of Boolean Algebra in the first video, today we're going to see some demos and some games that you could go ahead and play, um, which is just for fun, to be honest. So let's see. We're going to look at Boolean Algebra applications. Remember I told you about the searches, like all the search engines are using Boolean operations like and, or, and not, for example. And you have much more. We're just going to stick to these three basic ones to identify specific web pages. So when you're looking for something in a web page, what happens when you type in something? Google will actually go ahead and search every single page that it has to see if the word that you specified is there in that page. If it has got it, it will rank it. It's got its own ranking methods and it will show you everything. But what it will ultimately provide you is a huge list which you may or may not need. So if you need very specific information, you can actually enhance or update your search in a way that it only searches those specific stuff. Okay, so we're going to look at a demo now. So I've got my Google here. Now I'm going to go to images so that it's more visually easy. So let's see, I want to search everything which is woods and trees and grasses, for example, right? I want to search something which either of these comes up because I just want to see some greenery at the moment. So I say trees and I give or because like if either of them are present in the image, you can give me. I'll tell you why we have to say three R's. Then I have grass or and or. I say woods. So if you see, I've got grasses, I've got trees, I've got woodlands, everything that's coming up, right? Very nice pictures of everything. So if, like when it's searching, it will search, is this trees or grass or woods? If either of them is yes, if at least one of them is yes, it will add to the list of things that it has to show it to you. Okay, so that's how OR operators behave, remember. So if at least one of these three is true, that means so that particular picture will be added to the result set. So it shows all of these. Why am I saying calling it as three ORs? Because it needs to know that you're talking about the Boolean operation R. So it is actually padding it. It's if only when you say three ORs, it knows that it is a Boolean operation R. Otherwise, it assumes that is one of your key search or keyword that you're searching. It assumes that OR is also part of trees. So to just differentiate between what is OR Boolean operation and a normal OR term that you would use in English, you have to give it as three ORs. Now let's change that and say instead of OR, I am giving AND. What's going to happen? It will return me only those where the both you can see trees, grasses, and woodlands. So now the result set has changed totally. If you see, there is no more just grassy areas where your pets are allowed to go and just have a good run. This one now it's restricted the search because if you see this picture, this has got grass, this has got trees, and this has got woods. Only when because of all three are actually there, it returns me this. So again, you've got woods around here, you have grass, and you have a lot of trees. So I mean, can you see the change in the results that you have got? Okay, and let's say grass and trees and not woods. So it's got trees, but not necessarily woodlands. So it's kind of trying to filter it again. Let's see what happens if you say not grass and not woods. It's going to just show me simple trees, not grasses added to it, not woods. Of course, it will have a few of them, but still, the main focus is all about the trees. So this is how you can say that I want to search for a particular thing, not, I mean, if I just say trees, grass, and woods, if I don't do anything at all, I say trees, grass, and woods, it's going to go to the first one where it uses an or operation by default. It says, oh, either trees or grasses or woods. So it's by default doing an or operation. But if you want it to be very specific, you have to add those and or not. If you want to actually exclude a few things, you can do a not operation. Okay, so that's how you can use it for your searches. Now, logic circuits. So we already talked about how computers are built using electrical circuits, right? If you open up your computer, you can't really open up your laptops anymore. But if you have a desktop, or if you search for the computer circuits, you have these teeny tiny microchip thing that has so much lines on it. All those lines are actually circuits, like the ones that you have at home for your switchboard or for your lights or for your lamps. So you have millions and millions of such circuits inside your computer. And because the Boolean operations always deal with either 0 or 1, that is true or false or yes or no, it is easy to represent them using like electrical circuits, because they also have only two states. They have either an on state or an off state. So your light can either be on or off. It can't be in between. There's no in between state there. Your kettle can be either on or off. Your cooker could be either on or off. So there is no intermediate state at all. That's why Boolean algebra works very well with electrical circuits. Now, do you remember this? I mean, can you see the symbol over here that you always see in your phones everywhere? This power symbol is for use a toggle switch. Why? Because if you press it once, it's on. If you press it again, it is off. So it's got 1 and a 0 in it. So it is a toggle switch which has got both operations. So first time if you press, it's a 1, so it's on, it's true. The second time you press it, it is off, it's false, it's 0, right? So that's where the symbol came from. And if I want to represent the and or a not operations in terms of how the logic circuits are done, it looks like this. So in OR gate, if either A or B or both has set to true, or if you have them on, if the switches of both of them are on, the Q will be on. In AND gate, if both of them are on, then only Q will be on. NOT gate, if A is on, Q will be off. But if A is off, Q will be on. So they've got different symbols, so we don't confuse us with other things, and it's easy to draw it also. So if I'm going to design a circuit for my house and give it to the electrician to actually do it, then I can just tell him that this is how I want it, and he would know what each symbols mean. So that's why we represent everything using symbols and diagrams. Okay, so let's go to a demo again. So you've got a logic simulator. It's called academo.org, Demos Logic Gate Simulator. I've got an on and off switch here. This is my output. I'll show you one more website where you can use it. Let me add one more input. I've got input all the gates here. I say add. So I've got 2 inputs now. All right. And I'm going to go for an OR operation. So I'm going to add a OR gate. So this is my first circuit I'm going to draw. So I drag and drop to this one, and drag and drop to this one, and then drag and drop to this one. So this is my on-off switch, right? What if I switch this on? Can you see the light comes on for the output? I switch this off. I switch this on. The light comes over there. So it works perfectly fine. So if either of them are on, the the light comes on the output. Now both of them are off. That means both of them are zeros. There is no output. What if I switch on both of them? It's still on. So this clearly demonstrates how the OR operator works. Now let's go for an AND operator. I add the node. So I connect this one to here, this one to here, and connect the result of the AND operator or AND gate, which we call them, to the output. Now I've switched both of them off. I switch one of them on. What has happened? The output isn't glowing. Why? Because in AND gate, it doesn't work if one of them are on. You need both of them on to actually enable the output. So that's how AND operators are different from the OR operator. So you need both of them to be switched on for your output to be switched on. Now for NOT operator, I said we don't need two inputs, we need only one. So let's see, I've switched it off now. So I've got only one, and here. Now can you see this is off, but my output came on. Now what if I turn this on? The output is off. So this is how the NOT operator behaves. So it's as simple as that. So this website actually, I'll put up these websites in the description so you can have a go, actually helps you to understand better the three basic operators. We'll also come to a topic of how you can use a combination of these three operators. And also there are other operators as you see here, NAND, NOR, XOR, which we are not doing as part of this video because that's slightly on the next level. So you need to understand the basics first. So on this video is all about the basics. So if you find this is not very visually appealing, there is also another website where you can actually use a toggle switch, a button. So it's the same, it behaves the same. So you have these two, you have a OR gate over here, and I have a light bulb. So you can connect this to this to this, and just to the light bulb. I switch either of them, I can switch on the light bulb. Okay, if I don't want this, I delete that and then add an AND gate. I can connect and connect here, and no, it doesn't switch on. It doesn't switch on either, but if I switch on both of them, it lights. All right. Similarly, I can do the NOT gate where I have only one of them. So I connect this and this, and see it's already on. If I switch it on, it's off. So all you have to do is choose something, and you have a delete button here. So click on that and it deletes it for you. Okay. So now we know a little bit about the basics of Boolean operations or Boolean gates. There is a game that, again, I'll put all these links in the description of the video. There is something called a Boolean game, which I highly recommend you to do it. So this uses the Boolean logic, but in a slightly different fun way to do these kind of combinations. Okay, so you have a game settings here where you can say tutorials or sounds if you want to enable them, and you can reset to factory settings. Let's go to factory settings, and you can play the game. So have a go at it. So how would you actually get this sorted? So you can have a union. It explains to you what this is and tells you what to do. So it will tell you like, okay, if you want to do this, how does it actually do it? So that's another game that you can try. Have a go at this, because if I explain to you a lot of stuff, then it'll become very boring for you because you have to explore. Okay, I'm not going into depth in this case. Again, we can also combine all three gates to create circuits. Now, for example, let's take in your car, when you're sitting in a car, what happens? So you'll have a buzz coming in your car. Let's say you have 3 operations, right? Let's go to this one. So it should actually do a buzz in certain situations. So when will the buzz happen? Let's say let's assume this is a door which is open, and then I have got another switch which is the key in ignition. Okay, so I'm calling this to be uh, uh, door open. So this is going to be my key in ignition. Okay, and then I'll have, if the car is in a drive, so this means car in drive mode, and I have one more for as input, which is like seat belt in place. Okay, so I've got 4 now. So let's say, when should the light on, or the alarm or the signal should be on? If the door is open and if the key in ignition is on. So like if the key is in ignition already and you have left the door open. Okay, so in this case, what should happen? Should it buzz? Because the key is in ignition, you have left the door open. What happens? What do you see in the car? It keeps buzzing. You say beep beep beep. You know. Now let's say the car is in drive mode. I like to actually do this quite a lot. When someone is going to drop me home, the closer they get to my home, I immediately unbuckle my seat to get down, right? The moment I unbuckle it, it starts beeping. It starts buzzing, saying that there is a problem. Someone has actually unbuckled their seat. So this is my seat, right? So if the seat is not, that means it's a very English term, but we're converting it into logic. If the seat is not buckled and the car is in drive mode, that's again an and gate, right? I'm saying and. If the seat is unbuckled or not buckled and the car is in drive, then also I should make a buzzing sound. No, I've got 2 and gates and 1 not gate. So this is where the door is open and the key is in ignition. So someone has actually started the ignition, but someone else has kept the door open yet, or they have not closed the door properly. It has to beep. And in this case, a car is in drive motion and someone unbuckled their seat. What should happen? Now, in either of these cases, it should buzz. So for the either case, I would use a OR gate. I would say, if any one of these is on, let me switch all of these off. I have to put this on. Now see here, that means the seat is buckled. So it will mean give you the alternative or the wrong one, but still fine. Okay. Now will it still light up? No, let's see. I have put on the ignition and now someone's not locked their door. Beep, there is a sound. Hello, you have to check your door now. Now that's all going fine, but what if someone has unbuckled the seat and the car is in drive? If they have buckled their seat, it's fine. But if the moment they unbuckle their seat and the car is in drive mode, it beeps. And if all of them are there, it still beeps. So this is how the circuitry in your car is also designed. So if you see a lot of Boolean operations everywhere. So that's wherever the electrical circuits are used, you will be using Boolean operations. And what we have seen just now is just 3 preliminary ones. And see what you can achieve just with those 3 things. So Boolean algebra is very, very, very important in day-to-day life. It's slightly difficult to comprehend and make sense of it. But once you get it, it's much easier and much fun to learn more. So that's the end of our Boolean algebra videos. Hope you enjoyed it. Have a good day.